Welcome to all my YouTube channel. This is Rena and you are watching Alchemist. My first lecturing started with coordination chemistry. In this lesson, including introduction of coordination chemistry, representation of coordination compound, coordination number, and classification of ligands. Firstly, we discuss about introduction of coordination chemistry. What is coordination chemistry? Coordination chemistry deals with the study of coordination compound or coordination complex. What is coordination compound? A coordination compound consists of a central metal atom and its surrounding so many ligands are located. The ligands and the central metal atom linked through a coordination bond. The definition of a coordination compound is a coordination compound or a coordination complex consists of a metal atom or ion is called coordination center and a surrounding array of bound molecules or ions that are in turn known as ligands or complexing agents. A coordination complex consists of a metal atom or ion is called coordination center and a surrounding array of bound molecules or ions that are in turn known as ligands or complexing agents. Those compounds retain their identity even when dissolved in water or any other solvents, and their properties are completely different from those of the constituents. Those of the those compounds retain their identities even when dissolved in water or any other solvent, and their properties are completely different from those of the constituents. I generalize that the coordination compound retain their identity in solution as well as in solid state. The coordination compound retain their identity in solution as well as in solid state. Such a compound does not answer the test of all ions by they formed. Such a compound does not answer the test of all the ions by which they are formed, but it also answers new type of ion test called complex ion. It also answers new type of ion test called complex ion. Here I given a table. It distinguishes central metal atom or ion and ligand. The central metal atom acts as a Lewis acid and the ligand acts as a Lewis base. The central metal atom acts as a Lewis acid and the ligand acts as a Lewis base. Lewis acid means Lewis acid is a electron acceptor and the Lewis base is a electron donor. So we can say that central metal atom having vacant d orbital and the ligand having lone pair s. Next point is the metal atom is a electron deficient and the ligand is a electron rich. The metal atom is a electron deficient and the ligand is electron rich. The last point is central metal atom acts as a electrophile and the ligand acts as a nucleophile. Metal atom acts as a electrophile and the ligand acts as a nucleophile. Next is representation of coordination compound. we already says that a coordination compound containing metal atom and its surrounding so many ligands are located. The metal atom and the ligands surrounded it are arranged in a square bracket. The central metal atom and its surrounding ligands are arranged in a square bracket. The whole part of the square bracket termed as coordination sphere. The whole part of the square bracket is termed as coordination sphere. The outer portion of the square bracket, it may cation or anion, it termed as ionization sphere or counter ion. The outer part of the square bracket, it may cation or anion, that is termed as ionization sphere or counter ion. Here cobalt is central metal atom and amine group act as ligands. The cobalt atom surrounded by a 6 amine group. So the count of ligands called coordination number. That means how many ligands are surrounded by a central metal atom, or how many ligands are directly linked with the central metal atom, that count is called coordination number. Coordination compounds are two types: neutral molecules, ionic molecules. Neutral molecules means the complexes have neutral charges. That type of complexes are called neutral molecules. In the case of ionic molecules, the complexes have negative or positive charge. That type of complexes are called ionic molecules. Negatively charged complexes are commonly known as complex anion, and positively charged complexes are commonly known as complex cation. Here I taken one of the example of each type of molecules. Neutral complexes example is triamine trichloro cobalt. In the case of ionic molecules, the complex anion example hexacyanoferrate 3-, example of complex cation hexaamine cobalt 3+. Next is coordination number. Coordination number means the total number of ligand attached to the central metal atom. More precisely, we can say that the total number of donor atoms directly linked to the central metal atom or ion. The coordination number is the number of ligand attached to the central metal atom or ion, more especially the number of donor atom in the ligand. The coordination number are normally between 2 and 9. Most common coordination number exhibited by the metal atom is 2, 4, 6. But in some case 3, 5, 7, 8, 9 and 12 also occur. Here I given 2 examples. Let me see. In the case of hexaamine cobalt 3 ion, cobalt acts as the central metal atom and amine is the ligand. 6 amine groups are surrounded by the cobalt metal. In the case of amine ligand, only one donor atom, that is nitrogen. So the coordination number will be 6. Next is tris ethylene diamine cobalt 3. Here cobalt is the central metal atom and ethylene diamine is the ligand. 3 ethylene diamine are linked with the central metal atom, but its coordination number is not 3. That means ethylene diamine have 2 donor atom. So the coordination number become 3 ligand multiplied with the number of donor atom, that is 2, we get coordination number is 6. It is a very important. Once again, in the case of tris ethylene diamine cobalt 3, ethylene diamine have 2 donor atom. 3 ethylene diamine ligands are surrounded by cobalt metal atom, but the coordination number precisely we can say that 6 donor atom are directly linked with the cobalt metal. So the coordination number is 6. Clear? It is a very important. Classification of ligands. Classification of ligands based upon the number of donor atom present in the ligands. The ligand containing 1, 2 or more donor atom are known as unidentate ligand, bidentate ligand or polydentate ligands respectively. Firstly, monodentate or unidentate ligand. Monodentate ligand means the ligand share electron pair of single atom with a metal atom or ion. Monodentate ligand is the ligand share electron pair of single atom with a metal atom or ion. Examples: negatively charged ligands. F minus called fluoro, I minus iodo, O2 minus peroxo, CH3COO acetato, SO4 2 minus sulfato, NH2 minus imido, H2O3 2 minus thiosulfato, NO2 minus nitro or nitrito N. Here N means N acts as the donor atom. SCN minus thiocyanato or thiocyanato S. Here S or sulfur denoted as the sulfur act as the electron donor. NCS minus isothiocyanato or thiocyanato N. N act as the donor atom in this ligand. CNO minus cyanato, ClO3 minus chlorato, Cl minus chloro, OH minus hydroxo, O2 minus superoxo, CO3 2 minus carbonato, H2 minus sulfido, N3 minus nitrido, Cn minus cyano, ONO nitrito or nitrito O. O is the electron donor atom in this ligand. Br minus bromo, O2 minus oxo, H minus hydrido, SO3 2 minus sulfito, NH2 minus amido, N3 minus acido, NO3 minus nitrato. These are the monodentate neutral ligands. C6H5 thrice P triphenyl phosphine, C2H4 ethylene, NH2NH2 hydrazine, CH3 twice NH dimethylamine, C6H5 thrice AS triphenyl arsine, CH3NC methyl isocyanate, C2H5O C2H5 diethyl ether, NH2OH hydroxylamine, N2 dinitrogen, C2H5 thrice P triphenyl phosphine, C5H5N pyridine. The short form of pyridine is P5, PY, CH3 NH2 methylamine, CH3 thrice N trimethylamine, CH3CN methyl cyanide or acetonitrile, CH3 CH3 dimethyl ether. Here I given pyrazine structure. O2 is dioxygen. Next is monodentate ligands. In the case of neutral ligands which are given special names: CO carbonyls, NH3 amine, CS thiocarbonyl, H2O aqua, NO nitrosyl, NS thionitrosyl. Polydentate ligands or multidentate ligands. Polydentate ligands means the ligand having more than one donor atom. We can commonly say that polydentate or multidentate ligands. The ligands that are bonded to metal atom or ion through electron pair present on more than one donor atom called polydentate or multidentate ligands. These are act as a chelating ligands. Chelating ligands means it will form 5 or 6 membered ring including metal atom or ion, which is called chelating ring, and the complex containing chelating ring are called chelates. This type of ligands are called chelating ligands. The extra stability of the chelate are compared to non-chelate is called chelate effect. The extra stability of the chelate are compared to non-chelate is called chelate effect. Next is classification of polydentate ligands. Firstly, bidentate ligands. Bidentate ligands means the ligand having two donor atoms for sharing of electron pairs. It will form one 5 or 6 membered ring with a metal atom. Bidentate ligand having two donor atoms for sharing electron with the central metal atom, and it will form one 5 membered or one 6 membered ring with a metal atom. Examples: CO minus, CO minus, oxalator, it shortly oxo, NH2 CH2 CO minus, glycinator. It will short formed as gly or GLY. CH3 C double bond NO minus, CH3 C double bond NOH, dimethyl glyoximator. It will short formed as DMG. Here I given toplanatos structure. You can see the ring structure of toplanato. Next is N2 CH2 CH2 NH2 CH2 CH2 NH2, ethylene diamine. It will short formed as EN. Next is CH3 CH NH2 CH2 NH2 propylene diamine. It will short formed as PN or 1,2-diaminopropane. In the case of bidentate ligand, having some exceptional cases. See, the ligand like CO3 minus, CH3CO minus, NO3 minus, NO2 minus, SO3 2 minus, NH2 NH2, O2, N2, they have two donor atoms, but it acts as a monodentate ligand because they can form 2 or 3 membered ring including metal atom. There will more repulsion between donor atom and its electron pair. So, the ring is unstable by the steric strain. See the structure. The CO3 are linked with the metal atom with a 4-membered ring. Inside the ring, we can see a strain that will distorted its structure. So, it's unstable compound. In the case of acetato, it will linked with the metal atom. We can see the same strain as compared to CO3 2 minus. That strain will destroy the structure of that complex. So this compound is unstable. In the case of 3-membered ring, the NH2 ligand are linked with the metal atom. We can see the strain inside the ring. The lone pairs and donor atom are repel each other, so the structure will destroyed. So this compound also unstable. But in the case of large metal atom like lanthanoids, these ligands behave as bidentate ligand because of the bigger size of the metal atom. It will reduce the steric strain inside the ring. Example, NO3 minus behave as bidentate ligand in cerium complex, in which coordination number of cerium 4 plus is 12. Tridentate ligand. Tridentate ligand means the ligand having 3 donor atom for the sharing of electron with the central metal atom. Here I taken 2 examples, that is diethylene triamine and tertiary pyridyl. Next is tetradentate ligand. In the same way, the tetradentate ligand having 4 donor atom with the sharing of electron with the central metal atom. Examples are triethylene tetraamine, triamino triethylene amine, triamino triethyl amine. Last one is nitrilo triacetate. Pentadentate ligand means the ligand having 5 donor atom with the sharing of electron pairs. Examples are tetraethylene pentaamine and ethylene diamine triacetate. Next is hexadentate ligand. It is a very important. The example is EDTA, ethylene diamine tetraacetate. Here given the structure of EDTA, 6 donor atom for the sharing of electron pair, that is 2 nitrogen atom and 4 oxygen atoms. It is a very highly stable complex. It is used to hold metal ion in solution, trap Mg2 plus calcium 2 plus ions in hard water. EDTA4 minus is a very stable complex with Pb2 plus. It is a poisoning element which is removed from the blood and tissue with the help of kidney as soluble chelate. That is complexes of a lead Pb EDTA 2 minus. This is the structure of Pb EDTA 2 minus. Ambidentate ligands. Ambidentate ligands are monodentate ligands which have two or more different donor atoms that can coordinate with the central metal atom through coordination bond either of the two different atoms that are called ambidentate ligand. Ambidentate ligand coordinate with the metal atom through either of the two different atoms. It will form two different compounds which may called as linkage isomers. Example: SCN minus NO3 minus S2O3 2 minus CO CN minus SO3 2 minus NH2 twice CO NH2 twice CS CH3 twice SO. But except SCN minus NO3 minus S2O3 minus, none of these show linkage isomerism. Here I given NO2 minus how to linked with the metal atom and how to show linkage isomers. In NO2 minus, either N or oxygen are act as donor atom. Firstly, the nitrogen atom coordinated to metal atom. Next one is the oxygen atom act as a donor atom and it will linked with the metal atom. Similarly, SCN minus coordinate through sulfur and nitrogen atom. Firstly, the nitrogen coordinated to metal atom. Next is sulfur coordinated to metal atom. In the case of first one, nitrogen acts as the donor atom. In the case of second one, sulfur acts as the donor atom. Bridge ligand. Bridge ligand means the ligand having one or two different atoms have at least two lone pairs that are shared with two metal atoms simultaneously. This type of ligands called bridging ligands. See the representation. The ligand's two sides located two lone pairs. In the one side of the lone pair approaching one metal atom, the another side of the lone pair approaching another metal atom. In this way, the two sides of the ligands are approached by two different metal atoms. That type of ligands called bridging ligand. Bridging ligand are two types: monodentate ligand having two electron pair on one type of donor atom. Another is the monodendrite ligand having two electron pair on two different donor atom. First one, monodendrite ligand have two electron pair on one donor atom which act as a bridging ligand. Examples: H2O, OH minus, NH2 minus, Fe minus, Cl minus, Br minus, I minus, O2 minus. In the case of H2O, the oxygen acts as the donor atom. Oxygen having 6 lone pairs. The two lone pairs of the oxygen atom may share with two metal atoms. It will be act as a bridge. So this type of ligands called bridging ligand. Next is monodendrite ligand having two electron pair on two different donor atoms which act as a bridging ligands. Examples: SCN minus. In the case of SCN ligands, sulfur acts as one donor atom and nitrogen acts as the another donor atom. The lone pairs of the sulfur share with one metal atom and the lone pairs of the nitrogen atom share with another metal atom. Next is CO, Cn minus, NH2, NH2, NO2 minus, O2 2 minus, O2 minus, SO3 2 minus, SO4 2 minus, ClO3 minus, pyrazine. These are act as monodendrite ligand in the form of bridging ligands. See, the last figure is pyrazine share its two lone pair with two metal atom in the two sides. Last one is symmetrical and unsymmetrical bidendrite ligands. Symmetrical bidendrite ligands means the bidendrite ligand which have both donor atom are same. That type of ligands called symmetrical bidendrite ligand. It represented as capital A, capital A. The A denoted as the donor atoms are same. Next one is the bidendrite ligand having both donor atom are different called unsymmetrical bidendrite ligands. The bidendrite ligands having the both donor atom are different, that type of ligands called unsymmetrical bidendrite ligand. It is represented as AB, where A and B are the different donor atoms. Examples of symmetrical and unsymmetrical ligands are ethylene diamine, butylene diamine. These two are symmetrical ligands. And glycinato 8 hydroxy quinolinato are unsymmetrical ligands. Here I given the representation of attachment of symmetrical ligands. We can symbolically represent it L and a curved symbol. The two end of the symbol is right AA. This means symmetrical ligands. Example are given below. It is a complex of cobalt. The two nitrogen donor atom of the ethylene diamine are attached to the cobalt central metal atom. Next is representation of attachment of unsymmetrical ligands. We can symbolically written as L and a curved symbol. The end of the line firstly wrote A, next is B. A and B means two different donor atoms. Here the another example of cobalt complex. The three glycinato ligands are linked with the cobalt metal atom. The two ends of the glycinato ligands are two different atoms. One is nitrogen, another is oxygen. So, in the ligand having two donor atoms, one is nitrogen and another is oxygen.